This is Unit 1.3, Properties of Real Numbers, adapted from the Glencoe book. Please copy your notes. To begin, we're going to look at several properties. The first property I want to look at is called the commutative property. This should be reviewed, so you should be quite familiar with this. The first commutative property I want to look at is the commutative property for addition. And what that means is A plus B is equal to the same exact thing, B plus A. And A and B, and when you see me use C, A, B, or C, they're all real numbers. So A could be 5, B could be -20, C could be -1/2. They're all real numbers. Okay? But anyhow, the commutative property of addition says A plus B is equal to B plus A. So in other words, we're just flipping them around. And that just looks something like this. For example, if I do 3 plus 5, it's going to also be the same answer if I do 5 plus 3. So commutative property for, and the key is addition here, is the same whether I do the 3 plus 5 or the 5 plus 3. Where 3 is the A and in this case, the 5 is the B. So commutative means I'm switching them around, okay, for addition. You can also do commutative property for multiplication. This is what it looks like for multiplication. It says A times B is equal to B times A. Just like the addition, A and B are being switched. So where I had A and B, it now goes B and then A. For example, 2 times 7 is exactly the same thing as 7 times 2. That's called the commutative property for multiplication. Remember, there's two commutative properties. Commutative for addition or commutative for multiplication. I can do A and B for either one, or in addition I have also associative property of addition. Associative property can be written again for addition, where I have in parentheses A plus B in parentheses plus C is equal to A plus in parentheses B plus C. So when I'm adding, and notice the key here is A and B and C being added. There's no addition and then some division here, or addition and multiplication. All are the same. It's the associative property for addition. So all three of the items are being added. A plus B added to C. And all I'm doing now is moving the parentheses. The order is still the same, A, B, and C. And on the equal side, A, B, and C. I'm moving the parentheses. And I'll show you one where I do a little switch on this one to kind of confuse you, but it's to see if you're paying attention. Here's an example with actual numbers written. 3 plus 5 plus 4 is the same exact answer as 3 plus 5 plus 4. 3 plus 5 plus 4, this is going to be 8 because we do parentheses first, and 8 plus 4 is going to be 12. Same thing over here, parentheses first on the right, 5 plus 4 is 9, and then a 9 plus 3 is 12. So we see both sides are congruent. Associative property, again there's two, the associative property for addition, and we have an associative property for multiplication. Well, what does that look like? That one looks like this here. A times B in parentheses multiplied by C is the same thing as A times, now in parentheses, we move the parentheses from the front to the back, A times B times C. Okay, what does that look like? With numbers added in there, 2 times 7 is 14, and then we multiply the 6 is going to be the same thing as 2 times, in parentheses, 7 times the 6. So 42 times the 2 is going to be 84, equal on both sides. Okay? And again, on associative, I just move the order around. And I can do that because all of these are being on the multiplication are all multiplied. I don't have 2 times 7 plus 6. Okay? It has to all be the same. I do the same exact thing for all of them. All right. In other words, they have the same property on both. I'm multiplying for all of them. There's not one being multiplied, and again, as I stated, this one being added. They're all the same. Next item. Next property is going to be the identity property. And I have an identity property. Identity just means pretty much saying that when you look in the mirror, you get an identity of yourself. You see yourself, a reflection of yourself. essentially. Identity is A, if I'm doing for identity for addition, is A plus 0. Okay? A plus 0 is equal to itself. I can switch it around and do 0 plus A. It's still equal to A. Okay? It doesn't matter if I switch them around. A plus 0, 0 plus A. Okay? For example, 3 plus 0 is equal to 3. And if I switch it as 0 plus 3, still 3. This is identity. When I multiply a number when I add a number plus 0, it still equals itself. When I add a number plus 0, it's still itself, and that's called the identity property for addition. When I add a number, 3 plus 0, it still equals itself. So a number plus 0 is going to be itself, and that's the identity property for addition. Well, what's the identity property for multiplication? It's just 1. A, or any number times 1 is itself again. So A times 1 is still A, or if I flip it, 1 times A is still A. Okay? That's the identity property for multiplication. Whenever I multiply 2 times 1 or any number times 1, it's going to equal itself. So 2 times 1 is itself, which is 2, or 1 times 2 is still itself, which is 2. Here's the inverse property. Inverse property is going to be A plus negative A. A plus its opposite is equal to 0, or the negative A plus A is still equal to its opposite. For example, here's using numbers. 3 plus negative 3 is 0. Okay? Negative 3 plus 3 is again 0. So this is the inverse property for addition. Okay? Basically, you have $3 and you owe $3 to somebody else. You have no money. Okay? What does the inverse property for multiplication look like? First of all, we need to understand that A cannot equal to 0. It's just going to be A times 1 over A is equal to 1, which is also equal to 1 over A times A. Well, it probably looks better if I put some numbers in here, so let's put some numbers. It'll look a little easier and better. So 2 times 1 half is equal to 1, and 1 half times 2 is still equal to 1. It's probably a little easier if I do it this way. So 2 times 1 over 2, and that's what this says here, is going to equal 1. By cross multiplication, 2 and a 2 is 1, and 1 times 1 is 1, 1 times 1 in the denominator is still 1. Okay? So the inverse property for multiplication is going to equal 1. It's going to equal the reciprocal. All I'm doing is multiplying by the reciprocal. Right? Well, let me clean this one up just a little bit, because I have a sneaky suspicion that some of you may have some questions. What if I have, and I'm going to get a clean paper, and I'm doing the inverse for multiplication. Remember, you have inverse for addition and inverse for multiplication. Okay? So if I have 3, how do I do the inverse? You just multiply by the reciprocal. This is really just 3 over 1. Well, the reciprocal is going to be 1 over 3. It has to equal, in order for it to be an inverse, it has to equal back to 1. So 3 and the 3 is 1, 3 and the 3 is 1. Okay, and 1 times 1 is 1, 1 times 1 is 1. There it is. Okay? All right, let's go back to our original screen here. And let's look at the distributive property. I'm going to erase this here. And the distributive property is A times a parenthesis of B plus C equals AB plus AC, and B plus C is equal to, parentheses B plus C times A is equal to BA plus CA. It's probably better if I put numbers in this one as well. You're familiar, or you should be familiar with the distributive property. So in other words, if A is 3, B is 5, and 4 is C, what does that look like? By distributive property, remember what that means. 3 times 5 is 15, plus, and then I have to distribute the 3 to the 4. 3 times 4 is 12. Okay? And what does that equal here? I'm already getting to the next slide. It's 27. Well, this second part says I'm moving it around, I'm flipping, I'm doing B plus C times that. That means a 5 plus 4, I'm moving to the front. 5 plus 4 times 3. It's still the distributive property. Okay? 3 times 5 is 15, plus this 3 has to be distributed to the 4, is 12, which is going to be equal to 27 still. Both are equal. 27 does equal 27. Here's an example I might ask you to name the property. Example. Let's suppose I have 5 plus 7 plus 8 equals 8 plus 5 plus 7. The question is, which property is that going to be? Okay, we're going to start. Is it going to be commutative, associative, inverse, identity, or distributive? Well, I immediately know it's going to be an addition property. It's not going to be a multiplication property. And the question is, does it look like inverse? Inverse will equal, for addition would be 0. That doesn't work. Okay, let's look and see what else it could be here. It's going to be commutative property of addition. And some of you probably thought it was associative. Well, where I'm taking this whole thing, 5 plus 7 to be A, and the 8 to be B. So A plus B is equal to B plus, and again, that 5 plus 7 is a group of A. So A plus B is equal to B plus A. And it does almost look like associative where I moved it around. But notice, the parentheses move. I didn't pick this parentheses up, and I'm going to show you. I didn't pick the parentheses up and move this to 5 plus and then do parentheses 7 plus 8. I didn't do that. That's associative when I do that, and we didn't. Again, I say, this is going to be commutative property because the 5 plus 7 is considered, the whole thing is A, and the 8 is considered B. So A plus B is there, and then, again, the 8 is the B, plus 5 plus 7 is going to be the A, because that's the whole thing. And there are your notes for this section.